Hello and welcome to another LeetCode video. We're going to be doing problem number 735, asteroid collision. It's a pretty popular interview problem and an interesting question. So you're given an array of asteroids of integers representing asteroids in a row. For each asteroid, the absolute value represents its size and the sign represents its direction. Find out the state of the asteroids after all collisions. If two asteroids meet, the smaller one will explode. If they're the same size, both will explode. Two asteroids moving in the same direction will never meet, so just assume they're moving at the same speed. Okay, so for this first example, we have three asteroids. We have 5, 10, and -5. And so what's going to happen here is pretty straightforward. So these two are both moving right, and this 5 is moving left. So the 5 will collide with the 10. And then what's going to happen is the bigger of the asteroids will survive, which is going to be the 10. And so these two collide, 10 survives, 5 gets destroyed, so we have a 5, 10. Second example, we have an 8 and a -8. This one's pretty straightforward. So they're just going to collide, and they're the same. So they're both going to break, and then you're just going to have an empty array. Third example, we have a 10, we have a 2, and we have a -5. And so what's going to happen is the first thing that will happen is the 10 and the 2 and the -5 will collide. The -5 will survive, because -5 is bigger, and then the 10 and the -5 will collide, and the 10 will survive. So then our output is just 10. So hopefully you're getting kind of an intuition for this problem. Pretty much what you're going to be doing is you're going to have asteroids that are going to collide, and how do we determine if asteroids are going to collide? Well, it's actually pretty straightforward. So we're actually going to use a stack for this problem, and we're going to put asteroids on top of each other. And so let's show you what this looks like. So we're going to put asteroids on top. So let's actually look at this 5, 10, 5, and maybe we'll add some more numbers. So what's actually going to happen is we're going to go through this array of asteroids, and we're going to keep adding asteroids. And we're just going to check. So let's say for this first example, we add a 5. Obviously, with one asteroid, you're never going to have a collision. So then we can add the next asteroid. And then once we add an asteroid, it's going to be one of two cases, right? The asteroids are either moving in the same direction, which means they're not going to collide, or the asteroids are moving in opposite directions, in which case they are going to collide. And if there's a collision, we're just going to keep checking elements until there is no more collision. So like in this case, they're moving in the same direction, so we don't have to do anything. But now let's say we add this -5. So we're going to check the last two elements and check, are they moving in the opposite directions? And so yes, they are. So if they are moving in opposite directions, we're just going to pop them both and figure out what we need to keep. So we pop them both, and then we're going to keep the 10. So now we get rid of it. And now we check the last two elements again, and they are moving in the same direction, so we're done. But let's say we have some more elements. Let's say we add something like a -15. So we do the same thing, where we're going to check these two elements. They are moving in different directions. So now we are going to actually keep the -15 because the 10 is smaller. Now we're going to check the last two elements again, and we can see, okay, so this -15 is bigger than the 5, so then we're going to store the -15. And so that's pretty much going to be our algorithm. We're going to go through this array of asteroids, and we're going to just keep checking the last two elements, and we're guaranteed, like, if the last two elements are fine, then everything before that is guaranteed to be in the same direction already because we checked that, right? So if we had some elements, like, let's say they're all going right. Here we have a bunch of elements that go right. So just say right, and then we have another one that goes right. I'm actually going to use it right for R for right and left for left. So if we have like R, 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 and we have a left, if here, like, you could see that every asteroid before we added is guaranteed moving in the same direction. Otherwise, there would have been a collision before. So the only things we can happen is we're either going to have a bunch of asteroids that are moving right, and then we have one that's adding left, or we can have previous asteroids are all going left, right? Left, 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 left. And then now we have another asteroid. So actually, I think for a collision, technically, the only way you can have a collision is the asteroid on the left needs to be going right, and then the asteroid on the right needs to be going left. So if all these are going left, you actually can never have a collision no matter what you add. So you need something like this. This is the only way you have a collision. You need the asteroid on the left to be going right, and then the asteroid on the left to be going left. Because if you think about other combinations, so for right, right, there is no collision. For left, left, there is no collision. And then if you have left, right, that means they're moving in two different directions. So there's no collision there. So you need this combination is what you're looking for. And so that's pretty much going to be our algorithm. We're going to have a stack, and we're going to keep checking asteroids in the end, and we're guaranteed that if the two asteroids on the very end are going in the same direction, then everything before then was already, because we check for collisions for every single time we add something. Okay, so let's code that up. So we're going to have a stack. And now we are going to go through asteroids. So for asteroid in asteroids, we are going to append the asteroid to the stack. And now we are going to say while the length of stack is greater than or equal to 2, right? So until the stack is 2 elements or more, you can never have a collision. With a 1 or 0 element, there is no collision, and we're just going to have a break in here. So we're going to compare the last 2 elements. And remember, the only way that you can have a collision is if the last 2 elements, the left one has to go right, and then the right one has to go left. So we're checking for this case. So that means that the second to last element is positive, and then the last element is negative. Only way we can have a collision. Okay, so if second to last element, we can just do something like this. So we can just say if the second to last element is not positive, right? I don't think we can have a 0 as well. Yeah, we can't have zeros. So if the second to last element is not positive, which means, let's just say it's less than 0, right? Or stack -1. And so the last, so remember, it has to be right left. So if the last element is positive, that means we can also not have that happen. So if one of these two is the case, that means we're never going to have a collision. This element has to be positive, and this element has to be negative. So we can just have an OR here, and then we can just have a continue. Actually, no, we don't want to continue. We want to break, right? So we want to break because there will never be a collision. So we can just break right now. Otherwise, what we need to do, so now we know that the other case is now there is guaranteed to be a collision. So we're saying if this thing is left or if this thing is right, then we can break. Okay, so now we are guaranteed to have a collision. And so now let's actually, how do we handle a collision? Well, it's pretty straightforward. We are simply going to have the 2 elements. So we can just say left, right equals, actually we probably want it the other way, right? Yeah, so this is going to be the right asteroid and the left asteroid. So we're just going to pop twice. So stack.pop and stack.pop. Okay. So now what are the cases? Well, it's pretty straightforward. So if absolute value of left is bigger, so actually, sorry, we don't even need the absolute value. The left has to be positive and the right has to be negative. So if left is greater than absolute value of right, yeah. So if left is the greater asteroid, then the right is going to get destroyed. So we can just stack.append the left asteroid. Pretty straightforward. So then we have an L if left is less than absolute value of right. Then we were going to append the right asteroid. And then we have one more case if they're equal, so we can just, that's the other case. So actually we don't need to do anything in the last case because if they're equal, they both get destroyed, so we don't need to actually append anything. So we can just leave it like this. Okay, and then finally, I think we just need to return the stack, and that's going to be the final state of the asteroids, I believe. Let's see if I screwed anything up here. This code. Let's take a look. While length stack. Oh, right. This is silly. Okay. Okay, so it needs to be greater than or equal to 2 to have 2 asteroids. Okay. Okay, nice. And so, yeah. So let's think of the time and space complexity here. So for O, or for time, what are we actually doing? Well, we're going through all of these asteroids, and this is one pass. So this is going to be length n, where n is the length of asteroids. We're just appending them to stack and comparing asteroids to the stack. But the most times we're ever going to append asteroids to the stack is going to be n times. And then we're also going to be comparing elements maximum, roughly n times. So, yeah. So then that's going to be O of n. And for the space, so worst case scenario, all our asteroids are going, like, let's say all in the same direction, in which case our stack would actually be all of the elements. Like, let's say every element's going right, that you're never going to have a collision. So worst case scenario, we have n elements here. Okay, so that's going to be it for this problem. Hopefully you liked it. We haven't done a stack problem in a while, so I just wanted to do something like that, and an easier problem compared to all the hard problems of the day. So if you did like it, please like the video and subscribe to the channel, and thanks for watching. I'll see you in the next video.